All right, so let's see how you did. In this one, they tell us it's a rectangle with the height of A and the length of 2B. So since it says the y-axis bisects EC and RT, that means it cuts it in half. So if the full length is 2B, that each length on each side would be B, and the height would be A. So that would give us R being located at a negative B, 0. E is going to be at negative B, positive A, because we're going to go up A units. C, we're going to go to the right B units, and we're going to go up A units. So that's going to be B, comma, A. And then T is on the x-axis, so it's going to be B units to the right, and it's going to go up or down 0, so it's going to be B, comma, 0. And then let's look at kite. The kite, we have, it tells us the length of IE is 2A, KO is B, and OT is C. The x-axis bisects IE. So that means it cuts it in half, which means that these two are the same, so they're both going to be A. If it's 2A, then each take it, divide by 2, and you get A. So now, as we go around this, we're going to have B units to the left to get to K, so that's negative B going to the left, up or down 0, so that's going to be negative B, 0. I would be 0 on the X, A units on the Y, so we're going to go 0A. T should be located C units to the right, so that's going to be C, comma, 0, because it's on the x-axis. And finally, E, you're going to go left to right 0, because it's on the y-axis, and we're going to go down a negative A units. So let's go back and let's look at example 2, using variable coordinates. So it says the diagram shows a general parallelogram with a vertex at the origin, one side along the x-axis. What are the coordinates of point D, the point of intersection of the diagonals of the parallelogram ABCO? And how do you know? So one thing about our diagonals is that in a parallelogram, our diagonals bisect each other. If they bisect each other, that means D would be the midpoint for OB. It would mean that D is also the midpoint for CA. So how can we show what this point is? Well, we can show it by doing a couple different ways. We're going to look at finding the midpoint of our two segments. So the first segment, and it doesn't matter which one you choose first, we're going to go, and I always choose as I'm working these, I'll go from the right, I'll go the farthest to the right to my left, so largest and the smallest. It won't make a difference here because when you're adding, it doesn't matter which direction you start with. So let's look at the midpoint for OB. So we're going to look at OB first. So the midpoint, we're going to add our x's. Well, this is going to be 2A and 2B plus 0 divided by 2. Because the 0, remember this coordinate here in the origin is 0, 0. And then for our y values, it's going to be 2C plus 0 divided by 2. Now, we end up with 2A plus 2B over 2 and 2C divided by 2. So as I showed you before, they use 2 so that they can cancel out when you're doing the midpoint, so the 2 will cancel out. Now, because the 2 can go into both these, you can divide 2 by both, and that gives us just A plus B. And then this one here, the 2's cancel, leaving us with just C. So the midpoint for CB is going to be A plus B, comma C. So this is the point D is what we're actually finding. So now let's look at that just to make sure we did it right. Let's check the other one. So let's look at segment CA. So here's we start this one. We're going to do our, so this is once again point D. We're wanting to make sure that these two do match up. So we have 2A plus 2B divided by 2. And then we're going to take our y values, which would be 0 plus 2C divided by 2. Once again, this cancels here, leaving us with A plus B. This leaves us with 2C over 2, which is going to be just C. So that means because these two are the same, they match up, they both have the same point, then you can say that D is in fact the midpoint of these two segments. So our diagonals bisect each other because they both meet at the same point. So let's look at the next one. You can use coordinate geometry and algebra to prove theorems in geometry. This kind of proof is called a coordinate proof. So what we're going to do in this lesson, we're actually just going to set it up for this first one. And then we're going to come back in lesson 9 and we are going to actually solve the proof. So here's what they give us. It says plan a coordinate proof of the trapezoid midsegment theorem. The midsegment of a trapezoid, this is part 1, midsegment of a trapezoid is parallel to the bases. And 2, the length of the midsegment of a trapezoid is half the sum of the lengths of the bases. So the first thing we want to do is we want to figure out what is our given. Well, what they've given us is that MN is the midsegment of trapezoid ORAP. So that's what they told us. We're trying to prove the trapezoid midsegment theorem, which means that this has to be the midsegment. So what we're trying to do is we're trying to prove two things. The first one, which is 1, is that MN is parallel to the basis. So that means it's going to be parallel to OP, and that MN is parallel to RP, or RA, excuse me. All right. So that's the first thing. This is kind of what we're looking at step 1. And step 2 thing, what they give us here is that we're trying to prove that the midsegment of the trapezoid is half the sum. So we're trying to prove that MN is equal to 1/2 of RA plus OP. So to start this proof, we're going to list the steps that we need to take. We're not actually going to do it. We're just going to talk about what we need to do. So the first thing we need to do is we need to find the points of M and N. If we're going to prove that these are parallel, then we need to know what are the coordinates of M and N. So the first step is and we're going to use the midpoint formula. So use midpoint formula to find the coordinates of M and N. So that's the first step. So once we have our coordinates, how can we prove that the slopes, or how can we prove that these two lines are parallel? And we're going to use the slope formula. Because remember, we learned in lesson 7 that we use the slope formula to prove lines parallel, to show that we have segments parallel to each other. So we're going to use slope formula. To determine the slopes of MN, OP, and RA. We'll say and compare. Because we are going to compare them as well, we want to see that they are the same. And now the last step. So that's how we're proving the lines parallel. Now we got to prove that this is going to be half. So the way we're going to do that is we're going to have to use the distance formula because we're looking at the distance, the lengths of the lines. So we're going to use the distance formula to find and compare the lengths of MN, our mid-segment, RA, one base, and OP. So these are the steps that we'd have to take in order to prove this to be true. So in our next lesson, we're actually going to use the midpoint formula to find MN. We're going to use the slope formula to compare our slopes of MN, OP, and RA. And then finally, we're going to use the lengths of MN, RA, and OP using the distance formula to show that MN is equal to half of RA plus OP. So now, I want you to find room on your paper, so you probably have to go to the back page of lesson 6.9. And I want you to find the missing coordinates. So we have part A and part B here. So the figure at the right shows an isosceles trapezoid. Give the coordinates of P without using any new variables. So you'll have a few problems like this on your homework. Now, in order to find out point P, we kind of have to understand how they got the coordinates of C, of this point here, which is at C3B, and this is at 2F, 0. So remember, from each coordinate, imagine if you're starting at the origin and you're walking to each point. So we don't want to use any new variables, so we'll only use everything compares to the variables we've already been given. So let's start out by just looking at the first point, C3B. So how did you get this? Well, if I was to draw a line here, straight down, we would walk over C units to the right, and we'd have to walk up 3B units to get to this point. So this is C units this way. Now, that's how we get to point C. Now, how we get to point F, or 2F, would means we'd walk all the way over here 2F units. So that means that distance right here is 2F. Now, since it's on the x-axis, it would be 0 up. So the question is, how are we going to get over here to P, which means we'd walk how many units to the right? So we want to know how many units to the right are we going to get to P, and then how many units do we get up? Now, the up part is pretty easy. This is going to be the same because it's an isosceles trapezoid, which means these two lines are parallel. So these two will be the same. So this distance will be the same. So this goes up 3B. Now, so how do I find this distance here? If this full distance is 2F and this is C. Well, think about it if this. Let's say this was 6 units. Let's just put a 6 in here. And let's say this was a 2. The C equals 2. So how would you know this distance here? If it's an isosceles trapezoid, that means that this segment right here would also be the same, because these two sides are the same, therefore, and these would be right angles. So this distance right here would be the same as this. So if this is 2, that means this is going to have to be C. So if I was going to find this, I would do 6 minus 2 to get to be 4. So to do the same thing here, we are going to have to subtract out the C units from 2F, which means that this point here, you would take 2F, and you'd have to subtract out C units to get for your point P. So point P is going to be located at 2F minus C, and you're going to go up 3B units. So your coordinates here, like we said before, 2F minus C, comma, 3B. All right, so let's do the same thing. You have one more left. I want you guys to try to find the coordinates of point M and K using what you've been given here as point L, which is at negative 4A minus 4B, comma 5C, and then point O is at the origin. So pause your video now and come back and check your answers when you're done.